Just wanted to make a quick video about your pre-lab for experiment number 5. This is where you have an acid, which is called KHP, and you have a base, which is called sodium hydroxide, and essentially you're reacting the two together, and you're trying to decide what the molarity of your sodium hydroxide solution is. So what molarity is actually how many moles you have per liter of solution. So that's kind of what we're looking for here. And so the first thing we need to do is, in order to determine what the molarity of the sodium hydroxide solution is, we start with a known molarity of the KHP. So what we need to do with that first is find the mass of the KHP. And the mass of the KHP can be found because what you're told is the mass of KHP inside of a bowl, essentially. And so if you have the KHP inside of the bowl and you put it on a balance, you get a total mass, but it's contaminated because the bowl is there. So you have to take away from that the mass of the bowl itself. But both of those are provided. So you take the mass of the bowl and the KHP, subtract the mass of the bowl, and you get the mass of the KHP. Now, the other thing you need to do is divide that mass by the molecular weight of KHP, which is given. And so if you divide the mass by the molecular weight, we remember that the mass is in units of grams, the molecular weight is in units of grams per mole. So those units cancel or produce the units of moles. So this will give us the number of moles of KHP we've got. And, whatever that number is, let's just call that X for now. So you can figure out how many moles of KHP you've got. And in the experiment that you're going to do, you're going to react all of that KHP with associated NaOH molecules. So what that means is for every molecule of KHP, you're going to have a molecule of NaOH coming in to interact with it. So that means if moles tells us number of molecules, then we're going to have the exact same number of molecules of NaOH. So if we've already solved for X, that means we also have X moles of NaOH, which gives us the first part of what we need in our question of define molarity. Now, the next part is how do we find the volume? Well, the volume of NaOH is also part of this experiment. We have to add a particular volume of NaOH such that this reaction will happen. And your pre-lab actually states readings from a burette. So what a burette is actually just a long tube with a tip at the end, and on the side it's got all these little graduated lines. And so your burette will be filled with a sodium OH solution, and then you drip it into the beaker of your reaction dropwise, and you will start in a certain place, and after you're done reacting, that line, the edge of where your solution is, will have dropped down to some lower place, some final. And so what you're interested in is what is the difference between the initial reading and the final reading. And that difference, that delta, is your total volume of the solution. And all you have to do is express that volume in liters, and that gets you the other number you need. And then once you got those two numbers, you can calculate the molarity of the solution, and you're done. So I hope that helps, and let me know if you have any more questions.